This is the Amp Hour Podcast. Released December 11th, 2023. Episode 653. Benjamin Cabe knows Zephyr. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Benjamin Cabe from the Zephyr project.
Hi, Benjamin. How are you doing?
Good. How are you?
Good. I remember when you got hired, I was so excited. I think I mentioned it on the show before, but I was like, the Zephyr project is getting a developer advocate. It's Benjamin. I knew your background. My coworkers told me about having worked with you or worked near your work in the past, and I was like, oh man, I'm so excited that there is a user advocate inside this project that I use all the time. So thanks for getting hired. That's what I'm trying to say. Thanks for having a job.
Well, actually, I joined earlier, and we can talk a bit about what Zephyr is, although you've been covering it in previous episodes. But kind of along those lines, when I saw the job offering a few months prior to joining, I was like, oh, wow, this is me. Like, they are trying to hire me. And I was super happy to jump on the opportunity because, I've been doing open source and like IoT and embedded stuff for a while now, and it's been pretty fun.
That's awesome. Yes. Well, I'm glad it's worked out, and I've enjoyed hanging out with you at conferences and seeing the stuff you publish. Because, well, I guess we should start with some resources. So Benjamin does Tech Talks now on the Zephyr YouTube channel, and you have a blog where you cover kind of weekly news of Zephyr. So we'll link all of that stuff, of course, into the blog or into this post. So check out the show notes if you haven't already seen them. Let's start with what is Zephyr. That's a nice broad topic.
So officially, Zephyr it's Zephyr RTOS, right? Zephyr real-time operating system, which can be confusing or doesn't necessarily do justice to what Zephyr really is. So yes, in a nutshell, it is an operating system, like a small framework that you can use to run on top of your tiny devices and your microcontrollers to not have to reinvent the wheel when it comes to interfacing with all your peripherals. And like, you need some kind of file system. It's likely that Zephyr has some way to help you there. You need to communicate with a Wi-Fi chip, a Bluetooth chip. It provides all those facilities and more, actually, because like an OS would be really just the low-level primitives that you use to develop faster and really focus on what is your core business, like developing some, I don't know, PID algorithm, or like really what's your
widget thingy.
yeah, for example.
Yeah.
But yeah, like you really want to focus on writing your actual application and not reinventing like hardware integration. So Zephyr does that, and then it's essentially an entire ecosystem of everything you would need. It's a distro rather than an OS, just like you could compare the Linux kernel to Ubuntu. That's pretty much the way you could compare Zephyr to other real-time operating systems out there. Like,
yeah, but in that case, though, Zephyr is the kernel and is the distro, right?
Yes, exactly. So that's maybe some naming that we need to get right eventually. But I typically end up calling it an RTOS with batteries included, or like something along those lines. It's definitely the kernel that many people need, and many people don't necessarily need more than that. They want something that's going to help them move away from the dreaded super loop, kind of, right? Like you want to
dreaded. Yeah. Oh no! You're on a hardware podcast. The vaunted super loop, rather.
Sure, it is.
I can just do what I want, get to the bottom of my loop, and start again, Benjamin. Come on.
Yes, except that when you start doing tons of stuff, including potentially, which something is like historically, that's one of the strength and the origins behind Zephyr, things like internet connectivity.
Yeah.
You might want to have like some kind of multitasking and multi-threading at your disposal.
I learned the other day that Zephyr has a state machine architecture as well, and I was like, wait, why does an RTOS have state machines? Because I can just do state machines myself or do it, like in a super loop. But then there's obviously reasons. But it's just one of those things where it's the ecosystem and just the it's big, right? I mean, it's like a really big broad. There's a lot of stuff going on there, and you can plumb the depths of it and just keep finding new things within it, which is very interesting and maybe a little scary. Let's maybe call that out too.
Yeah,
Again, hardware people listening.
Yeah. Well, but I guess where Zephyr is trying to go, and luckily, I guess the fact that the MCUs are becoming more and more powerful is getting to this level where it's actually fair to call it an OS, in that there might actually be several people involved in eventually building the application. Like some people will take care of like the low-level hardware integration and potentially tinkering with really low-level Zephyr APIs, and then some people that are more like software developers rather than they are like embedded developers, like just regular, like they want to build a GUI and they want to like sit on top of something that's higher level than like the HAL that you get from STMicro or wherever else. And that's where maybe a state machine framework, it might eat up 100 bytes more memory, but it's going to make people's lives so much easier at that level, right?
That's an interesting point too, because like so LVGL support is like a good thing in Zephyr, I feel like, and then the software person might not want to be, bit banging on like a parallel display. Not they would be, but like, you could do that if you're into like a super low level embedded, but then you start going up into like these 3.5, 4.5, 5.5 inch displays, and it just becomes unworkable, and you need more kind of tooling there. So that's where that split, I feel like, starts to really come into play, but you're still in the embedded space. You're not like running a full OS on there.
Yep. Yeah, exactly. Yep.
Yeah. One other thing that I feel like that I always call out with Zephyr is the involvement of hardware companies. Like that to me is so different, because I use Zephyr a lot at my day job, Goliath, and we have different SDKs, and we do some free RTOS stuff. But whenever I talk about free RTOS, I'm like free RTOS, the RTOS, and then ESP IDF, the ecosystem. Right, so that's the expressive ecosystem on top of FreeRTOS, and then Modus Toolbox, the ecosystem on top of FreeRTOS. So there's all these just like vendor-specific ecosystems on top of FreeRTOS, which is like a kernel and it's an RTOS, right? And there's a framework, but like that is very different than. Maybe you could explain how it's different than from Zephyr.
Yeah, that's actually a good comparison. The way it typically works with Zephyr, and like you said, many vendors are really involved in like our platinum members of the project includes the like of Analog Devices, NXP, Nordic. It's pretty big about Zephyr. Typically, all those vendors, they have like their existing hardware abstraction layers that potentially they have their own like full IDEs based on top of, and usually like tons of interesting and good code samples if you want to stick to their story, let's say. But then they also work like pretty closely with the Zephyr community, so that right on top and like just on top of their HAL, they integrate with the Zephyr APIs. And so when it comes to interacting and interfacing with GPIOs and I2C and whatnot, like you typically have like the Zephyr ecosystem to make the parallel with the ESP IDF ecosystem. Yeah, that makes it really easy for you to like still have something that feels very much like the low-level stuff, except that you can move from one SoC vendor to the other. Like we have, I don't know how, I think it's like getting close to 600 boards supported in Zephyr, like as in just check out Zephyr, check out one of the hundreds of code samples we have, and it's likely that they will just run on whatever board you have on your desk.
Right.
This might not always be the experience when you use other ecosystems. Not saying that it's incredibly difficult, but like this sort of like really low.
I disagree with that, because like if Espressif has their own boards, right? If they have like, I think maybe the vendor specific boards, but then I think what you're maybe saying is the boards are also outside of the vendor made boards, right? So like an Adafruit board might be supported within Zephyr, whereas like an Adafruit ESP32 board won't necessarily be. You could probably like glue it together, or it looks kind of like in ESP-IDF, but it's not going to be directly supported.
Yeah, that's a really good point, and that's actually a great segue into one sort of like technical detail of Zephyr that makes everyone's life mostly better. It comes with headaches sometimes, but usually it's actually really, really powerful. It's this whole notion of the device tree. Just like, it actually comes from, is this a good thing or a bad thing?
No, it's
mostly a good thing.
This is pain. This is painful. This is what this is actually, so you and I got to hang out a little bit in Prague last year at the Embedded Open Source Summit. And the thing I keep talking about when right? So we were there talking about Zephyr. We love Zephyr. There was like a mini conference there, but there was also all these embedded Linux folks, and they all kept coming over and they'd be like, oh, I get all this, right? I get it. I know how it works because like I'm in embedded Linux. I do device tree. I do all this stuff. And I know like all these different paradigms. And I'm like, okay, well, I'm a hardware person. So like I'm moving, so going up the stack, I think is a lot harder than coming down the stack.
Yep. But I was sort of like, thinking about what you just described. Well, say there is the official ESP32 S3 dev kit from Espressif, and then there's a small variation in the form of whatever Adafruit provides. They have a couple additional LEDs and a button, whatever. What the device tree makes really easy to do is basically just describe, and pretty much in a declarative way, what's the mappings between the different pins. And it turns out that it might be just inheriting most of the stuff like the upstream ESP32S3 SoC and reference dev kit, and just tweaking a few things. In most cases, you don't even have to do this tweaking because someone has done it for you and it's already available as a supported board in Zephyr, and you go to the documentation and you have everything you need.
Yeah, it's very confusing at first. I mean, like, I think we should just be very clear about it. It is, so at least coming up the stack, like I said, I'm hardware dummy, I'm coming up the stack. Like, I was so confused at first. And my context with this was like, I had talked about building a board with an NRF52840. Everybody's like, oh, you should try this new thing, Zephyr. This was like 3 or 4 years ago. So Zephyr was a little bit less developed even than it is now, which has only been 3 or 4 years. And it's like, oh man, I had no idea what I was doing because I was used to like IDEs where it's like you're digging down,
Okay, so because of IDEs, because I was going to ask, like, do you think part of what makes it scary would be that when you integrate with whatever an RF chip, you really don't think or want anything to be particularly portable because you're doing it one shot? Because there's a bit of that. The overhead of device tree is also sort of the price you have to pay. Because
that's right. Yep.
You really want, especially in those times of like silicon shortage and stuff.
Oh yeah.
You add some level of abstraction, which sometimes might feel like it's too much or too complicated, but that's going to save your ass later when it comes to being like, totally. I don't want to use NRF at the end of the day. I'm going to go back to ESP32.
Yep. No. I like everyone I know who's done it and had to, like you said, with shortages, like it saved a lot of people's butts during the shortages. And I think that's actually what drove even greater growth. Like we saw some more silicon companies come into the fold during shortages. And I mean, I think they were getting asked by their customers. They're like, look, I'm coming from Zephyr. You got to support Zephyr. And all these silicon vendors are like, okay, yeah, fine. And that's why that's all great. I'm really, really happy. I mean, I'm sad about the shortages, but I'm happy about the net result. But if I had to qualify hardware people in like the things that I hear at like training, because I do some trainings, it's like, tell me where to click. Right. That's like the hardware person version of like at training, and like they're used to like, better or worse. They're like in Eclipse IDE with the vendor specific tools, and they're like, just show me where to click. Because at the end of the day, they want to like change the timer or change which pin it's attached to, right? Choose the little configurator thingy. And it's like it's tough because the silicon companies are incentivized to do that sort of thing. And now hardware dummies like myself have been trained to do that sort of thing. And so I think it's just a mindset shift. And once you get past that, then you're like, oh yeah, okay, now we're into it.
Mm-hmm. Yep.
I have lots of thoughts about this, Benjamin. you and me, man, we're gonna talk about this stuff and all the insecurities hardware people have. I will map to you.
Yeah, but I totally get the tell me where to click aspect of it.
Who is the target audience of? I mean, like, is it firmware developers first, you think, for Zephyr?
Define firmware developers?
Sure.
No, that's definitely the audience. And like I said, it goes all the way from really, really small and like completely headless, like hardly any human or even physical interactions to really, really big. Like you would find Zephyr running and powering. I don't have a Chromebook myself or a framework laptop for what it's worth. They also use like the embedded controller in those laptops. So not the main processor, but like rather the MCU or MCUs even, I guess. That's powering the laptop when like,
those aren't small though. Those are still powerful processors in there, right?
You know, but I mean, like when the laptop is in standby mode, there's still plenty of things that you want to do in terms of like charging the controlling the battery charge and like keyboard interactions, etc. Yeah, I'm actually not sure what class of MCU they're running, but yeah, the Chromium open source project has this project called the EC, the embedded controller, which happens to be based on Zephyr.
Yep.
So there's that, and then you would find Zephyr in tons of like wearables, and so.
What is the smallest part you've seen? So like again, like the context of the people that I talking on the show, Dave, my co-host, right? Like PIC 18, right? Can it run on a PIC 18?
So that would typically be 32 bits MCUs, and so you're looking at like we are looking at ARM, which you don't have to because there's like ESP, like all Extensa MCUs are supported, x86 and ARC and MIPS even. But
Neos 2. That's a throwback. Every time I see that, I'm like, oh, Neos 2 in my
and probably a few others.
2004 FPGA.
Cortex M0. Like you would look at like really really small. I think like 2Ks of RAM, kind of small-ish M0. You probably want to do a lot. Certainly not drive a GUI and things like that. But you will have like the kernel at your disposal, which is already quite good. Like if you want to have like those really like well scheduled and tasks and leverage the Zephyr scheduler to do a bunch of things in a timely fashion. Yep.
Yeah, no, I think that is another like kind of like where that line gets crossed as well from moving from Superloop is the right move in super tiny processors, but sometimes you want to maybe you do want to layer in some RTOS-ish elements, right? If you've got really tight timing, like you're saying, but you might not have stuff at your disposal. So it's interesting, like, but when you make that switch then, and I feel like when you get good at that, then you start moving up, you're like, oh, actually I need a little bit more power. You get more out of it, right? You still get the power savings nature of the underlying vendor support, but I'm saying like the starting to bolt new stuff on, it becomes things like enabling stuff in device tree and pulling in new drivers that are already in the ecosystem, and that's where I start to see like tons and tons of benefit.
And one area where also I really love like tinkering with Zephyr and is you don't even have to have the hardware at hand. Like there's tons of solutions out there to simulate, emulate. I don't know if you've had Yuri on the show in the past, but like things like Walkwee or things like Renode. Things like Renode, Walkwee. You end up building your firmware and your final binary, except that you don't have anything to flash it to. Well, you might as well use your browser or your desktop.
Yeah.
Even if you're using actual peripherals like a display or GPIOs, there's quite a few things that you can do. Either like you want to actually interact with the device as a human and like test the behavior there, or interact more in with an integration aspect in mind, and you can do lots of testing and like run unit tests and integration tests, even if you don't have the hardware.
See right there, unit test, integration test, right there. That to me is like you just caught
where do you click for? Where do you click for that?
All the hardware people, you just caught them snoozing. Right? And like you're saying, like, oh, you don't have to have the hardware, but like that's a bug, not a feature to me as a hardware person. I'm like, why wouldn't I have the hardware? I want to see the LED blink. That's what I bought this thing for, right? Like that's, but like you're saying, I think a lot of when you start to get to production and you're like pushing code changes and you want to make sure you're not screwing all your stuff that's out in the field, like, yeah, totally. Like all this unit testing and, CI.
Or when there's, and I get that this might not be always practical or might not reflect the reality of every development team out there, but another aspect is like there might actually be several people involved in like building the the full app. Like if you're building a smartwatch, I doubt that it's the same firmware engineer that's going to be doing the like low-level sensor integration, low power management, crafting the fancy GUI with like really responsive GUI, and God knows whatever else, like communication with an IoT internet cloud platform. There might be several people involved. It might be nice to be able to sort of emulate some kind of minimal functionality for each component of the system, right? And the Zephyr makes that pretty easy.
I have my vision of the person listening right now, and it's me. It's the lone wolf, Benjamin. The lone wolf hardware engineer struggling on the bench. They're sitting there they're listening at 2 a.m. They're soldering, they're swearing, they're drinking coffee even though it's 2 a.m. And they're like, I don't need device tree. I just write to the register directly.
Which is fair.
I know how to OR stuff together. I can bitmask. Yeah. But I think that's actually, so that's another interesting point too, is that like, so there's all these layers of abstraction, but you don't have to use all of them either. Like that's another thing that I feel like is important to call out, is that like, yes, you can use the Zephyr sensor driver or what is it called? A subsystem, right?
Yep.
But you can also do a raw I2C read or write, and I do that kind of stuff all the time to just hack around something.
Yeah, and either way is fine. And even if you start bypassing some of the subsystems and some of the higher level abstractions because you feel like you don't need them, you will likely still benefit from things like power management, etc. Like even if you go like really low, there will probably still be some level of Zephyr abstraction that will still make things better than if you had done like literally bare metal, if I'm making any sense. Like even if like the I2C write thingy that you're describing, it's still going to be done the Zephyr way, in that it might do some like fancy integrations with power management, and when you really don't need I2C anymore, you will maybe power off some peripherals and things like that.
Yeah, so maybe that's a good one. So one that I'm often doing is like using a BME 280, right? So that's like a Bosch sensor. It's in tree. It spits out. So I use that in the Zephyr sensor subsystem, and it's like literally like a couple lines of code, and it just spits out like temperature, pressure, humidity. Awesome. Like formatted data. I just like, that's so easy for me. But if there was a BME 281 that came out tomorrow and it was completely different for some reason, which would be terrible, I could go and I could start writing. I could go and read the data sheet, and I could say 0x84, right?
Here's how to spit out the temperature and humidity.
Yeah.
And then your code, like the one that's actually using the data, you wouldn't change anything, because it would just, what it would care about is getting temperature data from a sensor, and you can quickly reconfigure where you're getting the data from. It might even be a simulated one. Again.
Maybe, yeah. Yeah. I think that's another thing that's interesting. So we talked a little bit about the vendor involvement, right? And so you mentioned kind of like how they're tying APIs to their HAL. Like what does that look like? Because that's probably the level I think a lot of people are used to, like using like STM32 HAL, right?
Yeah, well, so I try to myself, not as a non-hardware person, I try to stay away from the HALs as much as I can. But typically, whatever you would do in like 30 lines of code to initialize your, like to bootstrap your STM32 whatever, and initialize your I2C and whatever it is you're going to need, like this is something that's already done as part of the integration with Zephyr. When you do Zephyr _ I2C init, say, it's going to be one line. Like under the hood, if for STM32 it turns out it requires like tons of register manipulation, etc., you won't have to think about that. It's already done for you, and regularly whenever the HALs get updates, because there's new SOCs, new optimizations, whatever, then you can benefit from that. But at the end of the day, as a Zephyr developer, you only care about, hey, I need I2C, I need to get info from the die temperature, whatever. And it's going to be, just a couple lines instead of thousands.
Yeah, no, I think that is, and it is kind of handing off some of that stuff, but I think because of the increasing maturity of the ecosystem too, it kind of quote unquote just works, right? It doesn't always just work, right? But it does just work, or you can find out how to make it work.
Yeah. And And to be fair, it also just works probably if you use the HAL straight from the vendors.
Yeah.
Especially since they have like IDEs and code generators that gonna take care of that complexity for you. Like those couple dozen lines of code that I'm describing, like I'm guessing most people don't write them. They either
go into Cube and
an existing boilerplate, exactly, or take a boilerplate hello world,
project.
And whenever they tweak anything to their clocks, etc., they just regenerate the code. But I guess the good thing with Zephyr is that even if you don't have an IDE or that kind of tooling support, it's fine. Like you really literally just write the code that matters.
Right. Well, I can imagine one argument against it is like, well, why even bother then, right? So like if I'm just going to be using something like an STM32 HAL or, I guess other vendor HALs, I could just use this directly. Why bother with another layer of abstraction on top, right? Like what are the benefits then, aside from like swapping out, what are some of the other benefits you get when you might be want to like tie stuff together?
Yeah, well, I mean, swapping out, at least in my book, it's still really high on the list because, like, for so many reasons, it's just great to be able to not be locked into a particular vendor or even just to a particular flavor of an SoC, a series of SoC, right? Like, you're studying M4 and maybe you're going to do M7 and you don't want to, like, change that much if possible. But then another benefit, like, is just the ecosystem, like in general, like things like you sort of mentioned it already, drivers, like you want a sensor driver that just works, it's likely already there. I mean, I love writing drivers, like in many ways it's fun and it's usually
what?
No,
all right,
I mean,
I'm calling you. I'm putting you on speed dial.
I mean, VME 280, like this one is probably pretty fun to implement.
Yeah.
Right. It's like just a bunch of, hey, here's where you get your ADC result and blah, blah, blah.
Yeah. You're saying like low level control and like peeking and poking registers, that sort of thing, right?
Yeah. But it's already available in Zephyr. You don't even have to do that. And then also the ecosystem in terms of like the infrastructure that you get for free. And maybe I will scare away some of your listeners there as well. But like CI/CD, as in like I'm making changes to my code. How do I test that it even compiles? Like, oh yeah, sure, it compiles on my laptop, sort of thing. But what if you you can actually really easily test that as soon as a commit hits your Git repo or whatever it is you're using to manage your code. You can actually like really easily at least just check that things compile, and you can even get to the point where you actually start running tests. But even just checking that things compile, that's actually a really nice smoke test already, right?
Yeah,
and that comes for free in that's just one line to enable in Zephyr, like to just ask the Zephyr build system to compile your code.
Yeah, I do think it's a little bit more. So one switch over that I had to kind of get more used to is running. I run a lot of stuff command line these days, and so like because there's no like official IDE, because there's different vendors and there's no like Zephyr IDE, you have to dig into the build tools a little bit more, and it's not going to be this like presented like, oh, there's been 3 warnings with here they are, and it'll like you can hook all this stuff up, you can make it work yourself, but it's not going to be like as direct of an experience, I feel like.
Yeah, I mean, I don't disagree like at all. When it comes to writing code and to being productive, when it comes to writing code, whether it's like really like actual new drivers and really low level stuff or really your application, I feel like things like VS Code pretty much just work when it comes to adding new code. Then when it comes to more like the tooling, the troubleshooting, and the where do I click experience that you were discussing, as in I'm starting from scratch. How do I create a new project infrastructure targeting this particular device, etc.? I feel that we certainly could use better tuning there. There are tools like what Nordic proposes that are actually really great if you're targeting on RF chips. It actually works quite well if you're targeting something else. So you can actually reuse a lot of the stuff for like manipulating all the kconfig configuration stuff and even editing.
That's right.
Editing the device tree, making sure that your device tree is syntactically correct, and getting a sense of what it is that you're overriding when you're like tweaking a particular device tree, so-called overlay. That kind of works, but like it's not the same fully integrated experience that you would get from a vendor. But then a vendor is a vendor. Like, I mean, as in they have like a commercial...
Like you're locked in.
Yeah, and I mean, you enter in a commercial relationship with them where, I mean, yeah, it's their job is to make sure that you're going to have the best experience. Zephyr as an open source project, so far, the main focus has been our job is making sure that we deliver on the promise of making something that's portable, that's as lightweight as possible. And we're not like, as a community, we're not IDE developers. Maybe we should.
Yeah, right.
But it's...
I sometimes forget that it's open source. I know that sounds stupid, but like, it is, right? I mean, like, that's actually what enables a lot of the vendors to feel comfortable, kind of jumping in as well to tie their stuff into the ecosystem. It's just like the open source aspect it's not as front of mind for me, but as the developer advocate of the project, I'm sure it is front of mind for you. Like it's like a topic that gets covered a lot too, like at conferences and stuff.
Yeah, and I mean, it brings lots of interesting benefits in that there's certainly, and historically and to this day, there's lots of really big commercial industrial players that get involved in the community, and they have like really serious business built on top of Zephyr. Like I mentioned, Google and like Chromebooks. Like for them, it's really important that Zephyr sticks around for a while. But then Zephyr being open source and being, I would hope, very welcoming to everyone, you also get like tons of hobbyists and just random individuals that happen to use it for their hobby projects. Like we did recently we conducted a developer survey. One thing that I was really impressed is that out of the hundreds of people who replied, several are like, oh yeah, I'm into custom keyboards and I'm a huge fan of ZMK. And I think your colleague Mike is is as well. But like
Mike, if you're listening, Mike, if you're listening right now, we love hearing about custom keyboards. Oh boy, do I hear a lot about custom keyboards.
But yeah, I mean, people who want to like customize the firmware of their keyboards, they happen to have a lot of fun with Zephyr and with ZMK. By the way, shameless plug, I think we're going to have a Zephyr Tech Talk about ZMK sometime in January. So maybe we can include the link if I have that ready by the time we go live. And what people said, and that was no news to me, but it's worth saying out loud, is that in the survey they were like, one of the reasons we actually use Zephyr is because it's open source, and like because we know that we're going to have access to all the code, etc., but we're going to have access to a community, and we also use it. And I'm really trying to quote people as verbatim as possible, but people literally said, oh yeah, like we want to give back. And so they use Zephyr, or they start looking at Zephyr because they know that soon enough they will likely have something to contribute back, improving the documentation.
Yeah, I did see the RP 2040 stuff. That wasn't like officially supported, right? But that was community support.
Yeah. As far as I can tell, like the Raspberry Pi Pico came from the community recently. Several of the Arduino boards, like Portenta, and what's the name of the one that came earlier in the spring? There's lots of like community support and community participation. Like every
although
week.
Arduino's a member of the
project, Arduino's a member, like, and they are actually
like
they are involved by themselves, but there's also community.
Yeah, it is that weird, like it's a binary nature of it all. So let's actually talk about that too, because that's kind of an interesting piece. We had kind of alluded to the idea of boards before, but it's like, again, it's like another like abstraction kind of thing where like a board is built on top of, is it a sock? Is that the family name? Or
yes, like I mean at a low level, like a few years back, because it doesn't happen that often, but a few years back, you would have had someone or some company who made the porting of Zephyr and the Zephyr kernel and the Zephyr primitives to a particular processor architecture. So that's where you would have like general support for, say, Cortex M.
Neos 2.
Exactly. x86 and Extensa, and like those really like at the architecture level, mapping to the primitives there. Like how do you implement a semaphore in really low level ARM code? And then on top of that, you would have SoCs, so more like specialized by vendor, and there might be some specificities in terms of how on a particular ESP32 SoC you're going to do I2C interaction. And this is where likely you're going to rely on the existing ESP32 HAL. This is where sometimes not everything might be supported. I know that picking on Espressif specifically, there's a lot that's supported in Zephyr, but things like, as far as I know, I2S, like for all things sound.
Right, yeah.
There is an API in Zephyr. It's not mapped just yet to the way Espressif does it. So if you were to be interested in doing I2S stuff in Zephyr on ESP32, like all the APIs will basically tell you that, hey, no, it's not available yet.
Yeah, there's nothing below.
But yeah, that's the SoC level. And then once you have that, then either someone has done that for you, or you're building your own PCB and your own board, and you're describing like the sort of the ultimate layer, which is what is the board? And the board is going to be a combination of a particular SoC, a particular memory configuration, like you might be on top of the existing SoC, you might have some external RAM, etc. And so this is where you would, I mean, when I say you, it's you if you are building your own PCB, or someone else has done it for you. Because again, like if you're almost 600 boards already supported, so if you're looking at STM32F746, like the super fancy
the Ethernet
F7 with Ethernet and really big LCD, etc. It's just there. And if you look at the code and at what's in the board's directory of the Zephyr source repo, you will find that it's basically describing, oh yeah, this particular board is made up of this particular SoC from ST plus all those peripherals that might or might not be enabled initially. And then based on whether you need them, you can actually enable them. And only when you actually enable them, you start pulling all the actual code, which makes for really modular applications. Like only the features you need, you end up in your code. So
yeah, I feel like this starts to match a lot of hardware workflows though too, right? Where it's like, I start from a dev board, and then I'm just gonna pull out the pieces I want. So for example, I made a board, and I didn't write the board file. That was Mike, my coworker, and thank you, Mike. But basically, it was like I started from Jared Wolf's NRF 9160 Feather, which actually then he also makes for SparkFun. So SparkFun's 9160 Thing Plus. But then that's got like a LAS2DH. It's got a battery charger. It's got the NRF 9160 on it.
Yeah. So and that was close enough to what you wanted to do.
Yeah. Well, I actually grabbed a bunch of that stuff. And another point that I always make is that when I'm searching for new parts that I put in, I usually go to the tree first and see what's in tree, because that's actually a benefit. Like this is like a thing that I tell vendors too. I'm like, hey, if you're in tree, I'm going to use your stuff, right? So it's like getting new vendors in there, especially like sensor vendors. I feel like that's a thing.
One tip for you there and for the audience, one thing that you should do as well is not only looking at what's supported in the tree, but usually there's a pretty big pipeline of pull requests and contributions from the community that are probably going to make it really soon. And like every week, there's a handful of new drivers that are supported by the community. So
Ben, how can I learn about these new drivers and new boards on a weekly basis?
Sure, let me tell you about that. But yeah, no, I mean, so oftentimes actually, like if there's really a really super cool sensor that you really want to use, it doesn't feel like it's available in Zephyr, make sure that you actually check if there's not a pull request from the community that's not about to be accepted, and or like there might be code out there, doesn't have to be in Zephyr, the code might be there.
Yeah, that's an interesting point. So like, because a lot of people like they stay in the Arduino ecosystem, for example, like the Arduino IDE, really, let's say what it really is, because there's a backend kind of like that XML file that kind of tells you all the boards and all the sensors. You can like pull in libraries like that. Like that's an ecosystem, right? That's something that's easy to kind of understand. And then I think the other thing is a lot of vendors finally jumped on board. They're like, oh, well, we have Arduino drivers too, right? We make sensors. We have Arduino libraries or something like it. That C++ code is relatively straightforward. Fine.
Yep.
We're getting there with Zephyr too, it feels like.
Yeah, absolutely. And yeah, I mean, there's literally like hundreds of pull requests and contributions every week, as in like new. On average, every week there's I think a dozen people who make their first contribution, or just like who have their first contribution accepted every week, every single week. So that's actually a lot of new blood. That's really cool. Like that's what you want for an open source project. That also means that it's hard to...
And as a user too, I feel like momentum is, to me, is like really important, right? So like I see, when I was like I said, 3 years ago, I was trying to figure out what to use, and someone said I should check out Zephyr. Another person said I should check out Minute. And I looked at both, and I'm like, Zephyr was what I chose. And Minute was another kind of ecosystem RTOS project that it's been flat, I think. But that is a indicator for whether you should choose this thing as well, right? I know that I'm evangelizing as well, but
it doesn't have to be the only. I mean, it's one data point. Like there's also there could be dozens of new contributors every week, and still we could have many other problems. Or the other way around, you can have something that's flat, like you said, that might not be a problem if this is like a rock solid code base.
Well, and if it's like they have a vendor support that's like super, super crazy good, right? If it's like you're going to use vendor excess parts and they support something like Minute, right? Fine, that might be the right call. You know?
Yes, exactly. Yeah.
Yeah.
But yeah, I mean, that being said, there's a lot happening in the Zephyr community. It can be hard to keep track. We try to do our best so that the documentation website is always up to date, and many people who are already well versed in Zephyr, I guess they know their way around the code. But if you don't, every week at some point, like I probably did a mistake when I started doing that every week, but that's pretty much the pace at which things go. Every week I try to post, I do post a Zephyr weekly update where I try to summarize what happened in the past week.
Yeah. And
it's usually a lot. Like I said before, it's usually a handful of new drivers, a handful of new boards that are supported, like an entire category of SOCs, like Renesas or NXP. They would have this new series of SOCs. Well, they do the great job of making sure that pretty much from day one, as the SOC and as their dev kit hit the market, it's already supported in Zephyr. And you would have like new subsystems and new really cool features that, frankly, you could easily miss. So that's actually why I'm trying to like spend a lot of time making sure that basically those tips and tricks that you can add to your belt, you get a chance to hear about them and to see them in action. Sometimes I try to put together short demos and things like that. Yeah.
So here's a good example from the December 1st newsletter that Benjamin sent out. The new recently added GNSS subsystem gets a generic NMEA driver, right? And that's probably anyone who's used like a GPS thing and had just like the flood of like these messages come through. You're like, what do I do with? You could write your own parser, but like, why, right? Like, there's no value in me doing that. Like that's where I start to see the value of this sort of thing. Of I don't want to do this work. I don't write good code, Benjamin. I'm not good.
No, exactly. And I think once you start like approaching things that way, exactly like you described them, then back to earlier in the discussion, then things like the Zephyr built-in state machine framework, maybe now it starts to make more sense, because you will be like, oh, but you know what? My NMEA frames, like sometimes there might be some situations where, I don't know, I want to do like geofencing stuff and have some kind of like, am I within the geofence, outside the geofence, and hook up an entire graphical user interface and some like business rules on top of that? It might be that, I mean, yes, you can switch case the whole thing in just like raw code, or maybe you can actually start describing things in like as an actual state machine and fit things in the framework that way, that you don't have to.
So one thing that it reminds me of is when Jay Carlson was on the show the second time, he had written, I don't know if you saw his post about like building embedded Linux. Did you ever see that post? It was like it was a tome. I'll send it to you after this. It's awesome. Really, really great post. He built like basically 10 systems, 10 like low level. He soldered the chip to a breakout board. He wrote the driver interaction. And one thing that he talks about that I always remember in this context too is he says, I'm often reading more code than I'm writing. Right. And that's kind of where Zephyr is going as well, where I would say my low level embedded stuff, I'm often writing more code than I'm reading, because it's just I got to write an interface to this register or something like that. Whereas with Linux, and now I think Zephyr moving up into that space as well, it is, you're basically figuring out what other people have done, hooking hooking the logic together, writing the digital wires, and then hitting go and seeing what happens.
Yeah, no, that's super interesting because you're trying to think about my own thought process, and that's pretty much how I do it. Like whenever I need to build something, I will probably spend a lot of time researching, because if I'm writing code, I feel like I might be doing it wrong, or like, you know what I mean? Like when you start doing like too much code, it's usually, it's fun. Again, back to, I'm going to write my own driver, but success often can be, I managed to just call this one API that does pretty much exactly the same, except that it's tested, it's been in Zephyr upstream for years, which means that it's already used in commercial products, etc. Why would I want to reinvent the wheel for this particular thing, right?
Well, let's talk about it. So you did this recently. So you had a project that was 2 years old. This is the profile photo that confuses me every time I see it.
Why does it?
Benjamin's
I'm French.
Because
I have the stripes and the hat and the baguette.
Well, I think it leans into the French thing, but it's really the nose, because it's like you're holding. So it's a 3D printed nose that you then hold up to your face, but it's because of the angle. So I'm like, what am I looking at here? It's because you're like,
so it works better on the full picture, which was actually the cover of Make magazine, which was kind of a nice surprise when it happened.
That's cool.
I think you said 2 because I told you 2 years, but it's actually 3 years ago. Like,
Okay.
Back at the beginning of COVID, I was like, okay, I don't know if I'm a maker, but I'm certainly like, I'm having a lot of fun with Arduinos and stuff. And one thing that I really would love to finally get my head around is neural networks and AI. And like, I'm a software engineer, but the math behind neural networks and all the tutorials that I would find out there, like, it would go above my head. Like even the things like, hey, here's how to recognize, like those black and white single digit, you know what I mean? Like the handwritten, right? It's supposed to be the 101 of AI, except that I don't get it. So I was like, okay, this is the beginning of the pandemic.
Just like Bayesian matrices. What's the problem? Like, I don't know. Like...
yes, and activation functions and...
right.
Exactly. And it's just like totally not tangible for me. And I was like, how come? And so this was the beginning of the pandemic, and I, being French and being sort of a foodie for the past couple decades, I've been trying to perfect my bread recipe. And I was like, hey, you know what? Maybe technology can help me. I know that things like gas sensors exist, so maybe figuring out when my sourdough starter is perfectly fermented, it should be a matter of like measuring how it smells. Like if it smells ripe and if it smells good, that should be it. Except that, how do you do that? Is this a bunch of if then else? Like if CO2 level is above XYZ ppm and volatile organic compounds in this particular...
Right, like manually, you're like saying like setting levels yourself, right? Versus like a machine setting.
But then how do you do that? Like it's like, and I was like, oh, that sounds like training. That sounds like a task for like, this sounds like deep learning and stuff. So I ended up like literally in a few hours playing with TensorFlow Lite for microcontrollers and Edge Impulse and Arduinos and gas sensors. And I had code and a device that I could train to recognize smells. Like here's good sourdough starter is bad sourdough starter, or is booze and coffee and tea, whatever. It works really well, even with a really cheap, pretty low quality gas sensor. And so I had that around, and it's been pretty popular when I started to like put it on GitHub, etc. But the code was terrible. It was like written like Arduino, like a patchwork of what I think and feel many people do when they do some Arduino stuff. It's just, like you said, it's super convenient to get libraries pulled into your sketches, and then you just copy paste sample codes and blah, blah, blah. So I had like 2,000 lines of really boilerplate code, which is too bad because I had people from all over the world looking at the project being like, oh, this sounds super fun. I'm going to build like, Benjamin, I've printed your 3D nose enclosure. I've ordered all the hardware. How do I change the code? No, don't look at the code. But now that I'm with Zephyr and like this is actually a perfect example and a perfect application for using Zephyr instead of using Arduino, in that I'm using Zephyr back to the very introduction of the podcast, using Zephyr as a framework. Like I need my artificial nose to do a bunch of things. One is regularly, kind of in the background, almost like acquire sensor data, like acquire and get readings from the gas sensor. And I want some kind of graphical user interface, and like I want to display like my sensor readings and whatever the nose is smelling, things like that. And like I don't want to think super loop when I do that. Like it's really literally like different tasks, different things that should run in parallel. And obviously another task is the one doing the machine learning inference. And so basically taking the data from the gas sensor readings, doing some stuff, and then making the data available to the GUI, sending the data and sending the results of the inference to the cloud is something that can easily be added as yet another task, yet another thread, however you want to call it. And so I ended up finally rewriting pretty much from scratch my boilerplate Arduino code in the plane taking me from Toulouse, France to Raleigh, North Carolina for a conference where a few weeks or a few months before I had applied and submitted a talk, which would be, hey, here's how I'm migrating my artificial nose from Arduino to Zephyr, except that I didn't get to actually do it.
No time like the present, yeah.
Of course, until I jumped in the plane. And so in a matter of hours, literally, in the plane, plus a few hours in my hotel room, which is why we didn't have dinner together.
Benjamin and I didn't get to meet. Right. Yeah. He was writing his talk, but no, that was also because I had a new baby in the house. That was the other thing. That's a real excuse too. Yeah.
But and so now, just like the original code is on GitHub, the new one is on GitHub as well, and I feel way more, if not proud, at least more confident that it's fine for you guys to have a look at it and see how things are done. I didn't end up using the state machine framework, but I've used a few similar things in Zephyr, like something that's called ZBus.
Yep.
Like so it's getting maybe too much in the technical details, but like really as I guess a software engineer as opposed to maybe an embedded or hardware person. In my head, the way I see things is that if I have a task, a thread that gets sensor readings from my sensors, and if I have other components in my system that care about getting notified when there's new sensor data available, etc., that's exactly how it should be done at the code level. And so ZBus allows me to have my sensor task or thread publish data to anyone who cares about it. In my case, that would be the GUI. Like the GUI wants to listen to new sensor readings. Whenever there is a new sensor reading, it sort of reacts to it.
Yeah, it's like a many to many kind of like subscription. It's almost like MQTT broker on the
exactly, because you have this notion of topics, and you can really have the data that you make available to others. It's actually like it's typed. Like you really you define actual messages, which makes for really like clean marshalling and marshalling of the data on both sides. Yeah, in a way that's portable, easy to maintain.
So I feel like there's another thing here too of like kind of this is like moving up in like complexity as well. It's like kind of starting to think about data. You're talking about threading, things like that.
Mm-hmm.
I feel like there's other, so like data is kind of like a high level topic, right? Obviously it's part of everyone's, designs usually. But like one thing is like the idea of like learning RTOS concepts as well, I think is another scary thing for hardware people. We had Brian Amos on the show who wrote a book about free RTOS. I love his book. It's called Hands-on RTOS with Microcontrollers. That was for free RTOS, but it could easily have been rewritten for Zephyr. And I just feel like that, like those concepts, they felt really scary to me at first. But then like things like work queues in Zephyr, I feel like that made things so much easier for me. Where I'm just like, it's just a thing it's basically like a super loop in kind of a section of memory almost. That's kind of like how I visualize it.
Yep. And the thing is that I think however scary the concepts may look like initially, I think it's just like often in engineering in general and in open source as well, the way I would approach it is that you need to scratch an actual itch. Like you shouldn't try and learn the concepts just out of the blue.
Yes.
It doesn't make sense. Like it's going to be really hard. Just like basically it's actually the example I was taking before with the neural networks. Like trying to read a book where it tries to explain to you how to do AI on pixels. If you don't really have a use case, I mean, your brain might be able to
immediate book on face. I'm asleep. Like.
Yeah, I mean, it might work if you're like still in a sort of if you're still a student or still in a learning mindset. Maybe you will get it, but I think in most cases, like if it's not directly applicable, it might not click. And so I think it's the same for the RTOS concepts.
Yeah.
Start with like an actual problem you want to solve, and then see what's available to you, right?
Yeah, I think. Maybe take the leap though too, right? So I think people should try this with different systems that are out there, right? They should try it with FreeRTOS, they should try it with Zephyr, they should try it with all these things just to see how it goes. But you're right. I think you have to have a project at the back end, or else it's going to be boring,
Yep.
What is your most recommended starter hardware? When you tell someone, hey, you should try out Zephyr, what do you tell them to go start with?
There's not just one, I think. Pretty much like
I love all my children.
Yeah, no, it's more in that like whatever, all the hero dev kits, for the lack of a better word, from pretty much all the vendors out there, they just work. So like usually, like I mean, it can start with as little as something that has a button and an LED built in, but I love LCD displays. So like if like getting the STM dev kits that I was mentioning before, where you already have an LCD display, that's pretty cool. These days, I'm also spending I think I actually did some of the portings in Zephyr for those, all the M5 stack ESP32 based kits are really, really nice.
Yeah, I think I saw you post about that one recently.
Yeah, like they're awesome, frankly, because they are small. They usually have a display. They usually have a battery, which is really cool. Like being able to sort of like write your Zephyr app, flash it over USB, and then actually unplug the USB cable. It's very satisfying, like to have the app that keeps running, right? And so yeah, M5 Stack Core 2, the Atom S3, those are all like really cool. They have some of them actually have like touch display as well. So running on those kits, which are really cheap also, running the Zephyr demos is usually a really, really good starting point. And then based on what, like, I guess I'm approaching or answering your question maybe more with a sort of maker hat on, or like more like with the DIY aspect. But then there's of course like other boards that are more geared towards more industrial use cases, like some that would have like Ethernet, some that would have like USB-C. It really depends. Like if you really want to, if at the end of the day you want to build a USB device, like a USB gadget, then you want a board that has USB support, of course.
Yeah, I mean, like, so I'm just looking at some of the recently announced, this is the one from November 17th. That's where you announced, there you have the M5 stack Atom S3 in there, and you got a little nice little animated GIF. But then right below it is the Verdin IMX8M Plus, right? So like a module, like a huge, that's a huge processor, first off, like an IMX8. So it is that, like, that scale difference is insane.
Yeah, and like there's 64-bit processors would be supported in Zephyr as well. Yeah, like it can get pretty big. It doesn't have to be small MCUs. I mean, you might want to build Ethernet switches and whatever, like those kind of pretty beefy use cases with Zephyr.
So in that case, though, so this is, I know we're getting up on time too. So like my last question on like, you know, people judging whether they should jump in and try this too. Like, where does this live in the, okay, so now coming top down, they're coming from a Linux world. When do you start putting Zephyr on something that beefy, or really when do you jump down into the Zephyr world from the Linux world?
That's a good question. Oftentimes people would do, there's no clear line, and oftentimes people would do both, and would have like on their design they would have an MPU and an MCU, where like probably the MCU would be taking care of the really low level stuff, like interfacing with a battery charger, a fuel gauge, and things like that. And the MPU is like really the end user, or like the high level operating system. And and you can still have some really tight integration between both, and like having shared memories and things like that. So oftentimes people would do it that way, keeping in mind, by the way, that Zephyr can run, if you have existing Linux code, it's likely that it can just run on Zephyr, like granted that it fits in memory, etc. But Zephyr effectively implements POSIX APIs. So if you have like even networking code and things like that, initially targeting Linux and a POSIX operating system, you could run on Zephyr. So that's
And so then the benefit in that case is just tighter loops, more real-time control. That's kind of the R in the real RTOS as well, right? But it feels like that's not often highlighted, right?
Yeah.
The timing aspect.
Yeah, exactly. Yeah, and I mean, not saying that this not something that would be available in the Linux world, but like also like tight timings and memory protection, and making sure that even if you're running on a small MCU, you can still have. I mean, the applications could run in user mode, right? Just like on the Linux operating system. If you're writing code, probably don't want the application to mess up with the low-level internals of the kernel. So that's also something that's possible in Zephyr, to make sure that applications run in isolation from the kernel.
Yeah, I feel like that's usually way above my pay grade, like when it is like that decision of like.
And frankly, for me as well,
Right, but then I can imagine teams. I have talked to some vendors. There's like some MCUs that are in Zephyr that are like kind of on the cusp of like this could probably run Linux if it had a memory management unit, right? But it feels like there's some cost benefits maybe too of like having a couple fewer components or maybe slightly smaller chips. Like sometimes there's cost basis kind of things as well.
Well, and the cost and the BOM also goes in terms of software. Like when you build something on top of Zephyr, it's going to be way smaller also in terms of what are all the software dependencies that you're pulling. And you're much more in control of the actual provenance of what it is that you end up actually running on your silicon. And should there be security issues, it's going to be easier to track, because you only rely on so many third-party dependencies. And from a safety perspective, it might also be easier to certify the behavior of the system, because you're only looking at a couple dozen source files that are making the entirety of your application, as opposed to Linux, where it might be slightly more complex.
Are you saying that apt-get isn't the way that I should pull in all my very secure files from various sources?
Probably, yeah.
It is amazing to me, like just how trusting I am. Yeah. I guess more broadly we all are, but just like it was like, yeah, whatever, bring some software into my computer, no problem.
Accept, download.
Yeah. Yeah. Well, this has been a great conversation, as I knew it would be. Benjamin, you have great experience here. We didn't even talk about your experience, I guess, but I enjoy hearing you talk about Zephyr, talking to you about Zephyr. And where can people hear you talk more about Zephyr?
Yeah, I think I did this little plug before. So we're trying to do more to push information to the community. So definitely like tune into our Discord, chat.zephyrproject.org. I think we just passed 7,000 participants there. And if you have questions, like actual practical questions, or just in general, you want to hang out with the community, it's pretty much where things happen. And then every other week, and I think in the new year in 2024, it's probably going to be on a weekly basis. We are starting to do Zephyr Tech Talks. So every Wednesday we do live streams. Yeah, we have like experts from the community sharing on some cool topics. I'm asking them to not bring any slides. So oftentimes they bring a couple, but that's fine. Yeah. But it's really not slides. It's like demos and like interactions with the audience. So it's actually been really fun to do. The weekly newsletter and our Zephyr Developer Summit in the spring, in April in Seattle. Probably put a link to the call for papers. I'm sure, Chris, you have already submitted something. If not, I'm pretty sure.
Well, here's the thing, Benjamin. I have not, because it is the week after Embedded World. How did this happen? Oh my God. It's like the week it's like Embedded World in Germany, and then the next week in Seattle. Like that's holy moly.
And I'm pretty sure, I don't remember, but there's usually Mobile World Congress pretty much in the same time frame.
Yeah,
that's
in
how
Spain,
it works.
Yeah. Oh, it's gonna be a rough April. Yeah, we'll see how that goes. Oh, you know what? It'll be an intense week or two, and it'll be a lot of fun.
Yep.
Yeah, and I think so. I've been to ZDS. It was ZDS the first year. It was EOSS with ZDS embedded last year, I guess.
Yeah, last year was in Prague in June. Yep.
Yeah, and Seattle this coming year. Great conference, really great crowd. Get to talk to maintainers, but users and vendors, and yeah, it's just I highly recommend it. I think it's going to be one of the few embedded conferences that it remains too, right? Like I don't know of other
there's the
conferences that are.
You're probably right. There's the Embedded Online Conference.
Mm-hmm. Yep. Yeah, I think in person. Like I used to go to what was it called? I can't even remember the name of it now. Yep. That's how long it's been. There was like one in Boston and in Chicago.
Oh yes, the one in Boston. I know what you mean. Embedded something.
Karen. Yeah. It's gone now, and there aren't many left, right? There's Embedded World, and there's going to be an Embedded World US this year in October. But, anyways, if you want to talk about Zephyr, that's the place to go. And there's other Linux things.
But I mean, ZDS is pretty. So the Zephyr Developer Summit is pretty awesome. But I actually don't mind online, like especially post COVID. It usually works all right. Not the same. You don't have like the always conversations. But in terms of sharing information, there's also a lot that can be done online, luckily.
Yes, agree. Well, thank you for being here, Benjamin. I really appreciate it. And I'm looking forward to many more years of me asking you hardware-centric questions around Zephyr.
Yeah, that was a lot of fun, and we should do that again.